Hello again. All right, our next graph that we are going to be learning how to make and learning how to read is a histogram. A histogram is another way that we can represent data. So what makes a histogram a little different is the fact that instead of plotting each number individually, we're actually going to be looking at ranges of numbers. So starting, I'm going to move myself over here, excuse me. All right, so to start off, it says a dog walker counts and records the number of dogs at a dog park every morning at 8 o'clock for several days. Make a histogram of the data. I love dog parks. I have 2 dogs of my own, so we go quite often. So let us try this. So if we look at the actual graph on the right side with the green bar that says dogs at the park, look at the x-axis. So we have ranges already set for us: 1 to 2, 3 to 4, 5 to 6, 7 to 8. So what we're going to want to do is take our data and put it in order from least to greatest. That will make it a little bit easier for us to read and interpret the question. So I'm going to go ahead and do that. So I'm scanning. The smallest number is 1. And again, I'm sorry for my handwriting. Looks to be only 1, 1, and then we have 1, 2 2s. So 2, 2, cross them out as we use them. And then we have some 3s. How many 3s do we have? 1, 2, 3, 4. 1, 2, 3, 4. Cross them out. All right, and then the number 4, we have 1, 2, 3, 4 4s. 1, 2, 3, 4. 5s, we have 1, 2, 3 5s. Cross out, cross out, cross out. 6s, we have 2 6s. We have 2 7s. I'm running out of room, so I'm just going to go put them down here. And we have 2 8s. Okay. So now that we have our histogram, we can go ahead and put the bars, or sorry, we don't have our histogram. We have our data in order from least to greatest, sorry. Now we can go ahead and put our bars in. So they want us to look at the ranges 0 to 2. So I have numbers 0 to 2 from here to here. So that's 3 numbers. So I'm going to raise my bar up into the 3, because frequency means how often do you find numbers between 1 and 2? And the answer was 3 times. Okay, so now we're going to look at the interval 3 to 4. So 3 to 4 is about here. I'm trying to change my color. There we go. 3 to 4 is in between here, and we have 1, 2, 3, 4, 5, 6, 7, 8 numbers between there. So I'm going to raise my bar all the way up to 8. I'm sorry, it's messy, but you get the gist. And then 5 to 6 is from here to here, and that's 1, 2, 3, 4, 5 numbers. I'm going to raise my bar to the 5. And then my last bar is 7 to 8, so I have 4 numbers between 7 and 8. So I'm going to go ahead and raise my bar there. And then notice how all of my bars are touching. That's important. Unlike a bar graph, histograms generally show numerical data, and they never skip a number. So notice how the intervals go from 1 to 2 and then immediately starts at 3. 3 to 4, and then immediately starts at 5. So they don't skip any numbers. So since they're not skipping any numbers, our bars should be touching. There should not be any spaces between the bars because we're not skipping any numbers in our number line. So there's our histogram. Not too bad, right? Here we have a histogram already made for us. No work to do there, but the question is asking us, a fisherman kept records of the weight in pounds of the fish caught on a fishing trip. The histogram shows his data. What are some conclusions you can make from the shape of the distribution? So notice we don't have any sets of data here. Like we don't have a list of numbers. All we have are intervals. So we have weights in pounds of fish, and we have how many fish were caught within those intervals of weights. So the yellow bar is definitely the highest, which means there were 7 fish caught between 9 and 12 pounds. So that's something we could write down. So 7 fish caught between 9 and 12 pounds. The second thing you can notice is that the blue and the purple bar are the same size or the same height. So you can say that the same number of fish were caught that were between 1 and 4 pounds and 13 and 6 pounds. So I'm not going to go ahead and write that because my handwriting is pitiful as it is on the screen. So you can just listen to what I'm saying. So the blue and purple bar, the number of fish that weighed 1 to 4 pounds and 13 to 16 pounds are the same. 2 fish were caught in both of those weight classes. We can say also that the majority of the fish were between 1 and 12 pounds. So I'll actually write that down. Majority of fish were 1 to 12 pounds. Because if you look, oh dear, that's pounds. Because if you look here, it is steadily increasing up until it hits the yellow bar, and then it drops straight down. So it's steadily rising. So the most of the fish were between that 1 and 12 pound mark, since that one purple bar is kind of left alone on the side. Things that you cannot describe. You cannot tell them the mean because you don't know what the individual weights of these fish were. You don't know how many fish were between 1 and 4 pounds. You know 2 of them were between 1 and 4 pounds, but you don't know if those 2 were both 1 pounders. You don't know if those 2 were both 4 pounders or if they were different weights within that range. So you don't know the individual weights of each special fish. All you know is that they fell within a range. So you can't find median, you can't find mean. We don't know if we have an outlier. We probably don't have an outlier because of the ranges going from 1 to 16, and there's groups within each classes, with each weight class, but you can't tell what the range is either because you don't know if there was a fish that was 16 pounds or if that fish weighed 13 pounds. You don't know what the largest fish weighed, you just knew it fell within that interval. So the only thing you can do is describe the way the graph looks, like saying that 7 fish were caught between 9 and 12 pounds, or how the majority of the fish were 1 to 12 pounds in size. So unfortunately, measures of center cannot be determined with a histogram. So this is as detailed as we can possibly get here. All right, so here we have another histogram example, but they want us to make a frequency table with the histogram. So I'm just going to show you real quick how to do that. It's not too bad. Notice down here at the bottom, they already told you what your intervals are going to be. So where it says age, I'm going to put those intervals. So we have 10 to 19 is our first interval. And then we have 20 to 29. And then we have 30 to 39. 40 to 49, and 50 to 59. Then where it says frequency, you are just going to put the number of values in your data set that falls within that range. So you can either use tally marks or just use the number. So 10 to 19, I'm just going to cross them out as I count them. We have 1, 2, 3. So 3 numbers in between there. And then 20 to 29, 1, 2, 3, 4. 4 numbers there. And then 30 to 39, 1, 2, 3, 4, 5, 6. And then 40 to 49, 1, 2, 3. And then lastly, 50 to 59. So 1, 2, 3, 4. And then just to make sure that you've got all of the numbers listed, I would count up your frequency and then count up the data points just to make sure that you didn't miss any. So now from here, we're just going to raise our bars. So from 10 to 19, we have 3, so we're just going to raise our bar up 3. From 20 to 29, we're going to raise our bar up 4 because that was our frequency. 30 to 39 up to 6 because we had 6 numbers in that range. 40 to 49, we only had 3. Come on. And then 50 to 59, we had 4. Notice again, the bars are touching because if you look at the intervals, they don't skip a number. They go 10 to 19 and then immediately go to the next number on a number line, which would be 20, and then 20 to 29, 30 to 39. Also notice that every interval is the same difference. 19 minus 10, that's a difference of 9. 29 minus 20, difference of 9. 39 minus 30, difference of 9. So on and so on. All the intervals are nice, neat, and identical. So that's something to remember if you're ever asked to decide on the intervals yourself. I hope that video was helpful. Now you guys are going to go ahead and practice reading some histograms. If you need to rewatch, please do.